I'm Stan Riddle with Realigning. Thanks for joining us today on our soft foot webinar. We're going to talk about a few fundamentals of what a soft foot is. We certainly are glad you attended. We hope that you'll get comfortable with this, listen in. We promise not to take much of your time, and hopefully this will be a lot of fun and informative. We're going to talk about what soft foot is. We're going to talk about how soft foot can affect your alignment. We're going to talk about some methods, different ways or methods of measuring for soft foot. And most importantly, we're going to talk about how to fix a soft foot problem so that you don't have those problems in the future. In the space below, you'll see an opportunity to send in questions. We would appreciate any you want to send in, whatever you want to talk about, as long as it's soft foot related from an alignment standpoint. And we'll try to answer as many of these as possible at the end of the webinar. Realigning just finished its 2015 Realigning America Tour. Went to several cities across the U.S. and at every location we went to, we found out that soft foot is listed as a major problem, one that can make a 30-minute alignment take hours or even days sometimes. So it is a big source of frustration in the alignment process. So what is soft foot? Basically, it's when one or two machine feet don't exist in the same plane as the other feet. You can think about the analogy of a table. If you see a table, and most everybody's been to a restaurant or somewhere at one time or another, where you sit down at a table and one leg's too short or maybe two legs are short, and this table tends to rock back and forth. We fixed them with coasters or napkins wadded up under that foot or whatever you need to do. But the table wobbles. Well, an electric motor does the exact same thing. It tends to wobble back and forth, and when it does, the shaft center line ends up in different places. Two types of soft foot, basically. You can have a parallel soft foot, where the distance between the bottom of the foot and the top of the base is the same all the way across this motor foot. Or you can have an angular soft foot. In an angular soft foot, it is a taper or a wedge shape, a slope underneath it, and it measures at different thicknesses of the gap depending on where you measure at. You can have one of these, you can have both of these as a combination. So how does soft foot cause problems in the alignment process? Pretty simple, really. You can have a good alignment, and then once you tighten the bolts, everything can change. Your alignment gets much worse. Or what is very common, and I've seen it happen for years, your alignment tool may tell you to add shims, say 50 in the inboard and 100 in the outboard. And you do that and you tighten everything down, and then it says take 20 or 30 out of the inboard and 40 or 50 out of the outboard, and you go up and down and up and down, and it's a point of frustration. And that's almost always caused by a soft foot problem. Reason why is this: as you tighten the bolts down, the machine shaft center line can pitch into different positions. And this makes your alignment measurements unrepeatable. Guys have tried for years to figure workarounds for these, and you kind of overcompensate with the shims, or you leave the bolt loose, or I'm going to tighten this one last because it always causes problems. There really is an easier way to fix it. Some people say, well, I'll just really tighten down good on it and get it out of the way. And the problem is you may cause more problems than you fix if you do this. You can bend or warp the feet of the machine. You can misalign the bearings internally on an electric motor, as an example. When you do that, you end up causing an eccentric stator. Bearing misalignment can cause bearing problems. Your temperatures and vibration can go up. So just really tightening down good isn't the way to fix a soft foot. So what do you do to fix a soft foot, and how do you minimize it? And let's spend a little time talking about that. You should minimize soft foot before you ever begin the alignment. You can leave your alignment tool in the box if you'd like. Just start checking around. Use shims to find a loose foot or a soft foot, see if they'll fit under. Shims really do two things. One is they change the machine's vertical shaft center line. They raise it or lower it. And the other thing a shim does is you correct soft foot with it. Before you attempt to fix the soft foot, whenever possible, the base of the machine should be clean, flat, and free from burrs, rust, paint, slag. Anything that gets between the bottom of the motor foot and the top of the base is a shim. so it needs to be clean. Your shim should be straight, clean, free of burrs as well, little bends and places in them. Shims aren't cheap, but you might as well use the good ones or you're just going to make more work for yourself. And I always recommend using pre-cut stainless steel shims. They don't compress very much, and they're nice, flat, and clean for the most part. We're going to talk about 3 mechanical measurement methods to check for identifying soft foot. One, you can use a feeler gauge or shims actually to check under the foot while the bolt is loose. You can use a dial indicator mounted on the foot of the motor and loosen and tighten the bolt. You can also put a dial indicator up on top of the coupling, and as you loosen and tighten the bolt, look for a response or a change from the dial indicator. Here's a little video that I think identifies this pretty well. Here we have we're using an NXA. We have a very good vertical alignment, right about 1/1000th of an inch or so. We'll rotate the shafts to the horizontal so we can see the quality of the horizontal alignment values. Again, really close, everything's green, everything's in tolerance. We'll roll back up to vertical because now I want you to see what happens when we start to tighten bolts. Again, we've got a very good vertical alignment value, but as I go around and tighten this inboard corner of the motor, you notice the values changing. And you see that what was pretty much a 0 value at the foot is now 5/1000ths too low. It needs to add some more shims. This is the typical response to when you have a soft foot problem. So a couple little shots here, how to manually check using a feeler gauge or shims. And what we did in this video is we actually just loosen up the foot, because only 1 foot at a time, by the way, if you really want to get rid of soft foot. And we're going to check around this foot in 2 or 3 locations. In this case, we used a 5/1000ths or a 5 mil shim. And we'll slide it in there, and it goes in the outside corner, goes in the inside corner, and goes in the middle corner here. So that 5 will go around in any place we check it. And if a 5 goes, then you ought to step to the next size up, and that's a 10. So we see that this 10/1000th shim will just barely go under one corner, but it drops into this inside corner. And you should always check in 2 or 3 places. You never know if you have a tapered or angular soft foot until you check at more than one place. You can use a dial indicator at the feet. This is a common method and one that I've seen in play for over 30 years now. You actually zero out your indicator right on top of the motor foot, and as you loosen that motor foot bolt up, you see a change in the indicator. As you tighten it back down, it goes back to 0. Now, that's a good way to find a soft foot, but the problem is the indicator and the wrenches often need to be in the same place, and that's pretty problematic. You can't always get everything in there where you need to be. So while this is a good check, if you're going to do it this way, you should move around in several different places at that motor foot and loosen and tighten. People don't do this very much, but you can also put a dial indicator right up on top of the coupling. In this video, we're going to put the indicator centered over the top of the motor machine coupling hub, and as we loosen it, we see a response or a change on the dial indicator. The entire shaft lifts up by that amount. Now, that's not the value at the feet, it is the value at the coupling, but it is an indicator that when you loosen that foot, it's going to change your alignment values because you can see it change with the indicator. You can also use your laser alignment tool to check for soft foot, provided it has an application for soft foot testing. A lot of the fixture laser tools that we sell have a soft foot application. Checking for soft foot with an NXA, you simply go into the soft foot application, choose the foot you want to measure. In this case, we're choosing the same foot on this electric motor. It zeroes out when you hit the button, and we'll loosen the bolt again and look for the response. We usually tell people give it 2 or 3 seconds to settle out, and we see that it goes up to about 8 mils. So again, everything we've measured has showed us that there's a soft foot on this motor. We've seen from about 5 mils to about 12. Now that may seem like a big swing, but it's really not that big a change. But what it does tell us is that there definitely is a soft foot on the corner of this electric motor. Now, when should soft foot be corrected? We hear this question a lot, before or after the alignment? The answer we usually give is both. You should minimize soft foot before the alignment begins, but you should also be aware of the possibility of soft foot occurring at any time during the alignment process. Something as simple as sliding in 4 20-mil shims, one under each corner. You may have what you thought was a 20, it could be a 15, so you actually put a soft foot in yourself. So be aware of it and just be tuned in to soft foot all the times during the alignment. You can suspect a soft foot when one of these things take place. Your alignment measurements are not relatively repeatable. When your numbers change dramatically, as we saw in the video here when the bolts are tightened, and when the shims can move even after the bolt is tightened down. Obviously the shim isn't carrying its part of the load if you can move it around underneath the foot after the bolts are tight. So some troubleshooting questions you might want to ask yourself during the alignment process. Does a particular bolt require more rotation than the others to get it tight? In other words, you may tighten one corner, it's only 10 or 15 degrees of rotation between snug and final tightening. You may go to the next corner and you may rotate it a quarter turn between snug and tight. It's a good sign that you have a soft foot on one that requires a lot of rotation. And again, do the shims feel loose? Can you wiggle them around after the bolts are tight? If any of these problems occur during the alignment process, you need to stop and find out why. If soft foot is minimized and controlled before the alignment begins, you'll one, save time, 1 or 2 spins and you can have an alignment out of the way many times. 2, you'll improve repeatability in your measurements. And 3, you'll improve your confidence in the tool. You'll learn to trust it a lot more if the numbers act like they're supposed to. If you expect 0 change or very little change between loose bolts and tight bolts, and you get that, you'll learn to trust your tool a lot more. So we're going to take a couple of minutes. Please send in any questions you have, and we will try to answer as many as we can before this webinar concludes. So thanks again for joining us, and thanks for sending in your questions. We'll try to answer as many as possible before we end this webinar. Before we get into the questions, I just want to mention, if you lose feed, you still have audio but no video, just please refresh the screen. We apologize for some of the joys of modern technology, but we do appreciate the questions you've sent in. It looks like Frank asks, what do you recommend for the maximum amount of shims before using plates to take up the gap? It's an excellent question. You know, shims are usually come in increments up to about a 1/8 inch, unless you make a special order. I usually recommend, first of all, no more than 4 shims per foot, if at all possible. Sometimes it's not possible. You're going to have to cheap put in a 5th one. But if you've got really big gaps, 1/2 inch, 3/8, something like that, you really should either purchase or make some plate to fill in those, and then use the pre-cut shims for the remainder. They do get, you can get a little compression, a little sponginess. One of the problems is when you have so many layers of shims, each layer of shim is another layer for air, dirt, grit, and things like that. So it's an excellent question, and we appreciate that. Lastly, on shims, make sure again, clean, flat, straight. Got another question from Tony. Says, how much soft foot is acceptable? Well, great question, and one we usually address in our classes. We usually say you want to try to correct soft foot to 2 mils or less. The benefit of that is the more you minimize soft foot, the less change you have in your values on the alignment between when the bolts are loose and when they're tight. The other thing you want to do is, in the real world, honestly, sometimes you're going to have 2 or 3 on each corner and you can't get it to 0. Just get it as close as you can. Try to minimize it, and I think you'll find you'll have a lot more quality alignment if you can minimize the amount of soft foot. So try to get it to 2 or less whenever possible. Thomas asks, what do you recommend the maximum amount of shims before using plates? 1/8 of an inch. If you go over an eighth, you know, if you need a quarter, cut some 1/4-inch plate. You can actually have them machined. I'd recommend, if you're going to cut shims, I would recommend having them cut on a milling machine and deburred and made as flat as possible. You know, I've done field work where you cut them with a torch and try to grind the sharp edges off, and try to just get them as flat and straight and clean as you can. We got another question from Phil, said, should you have equal shims in place on each foot before checking for soft foot? Depends. You know, we teach to rough in with a straight edge, but I would, as far as equal shims, I would make sure, you know, both inboards are about the same, both outboards are about the same, or drive in and opposite drive in. It's a good place to start, and it's always great if you can only have one shim under each corner. Start from there, start working your soft foot away, getting it minimized. But an excellent question. Rich says, how do you check for soft foot on a 30-ton generator? With a great big pry bar, I guess, Rich. But it's, you know, honestly, you get some big machines sometimes, big turbine generator sets, huge recip compressors and things like that. But if that foot is not going down, there's going to be a gap under that corner, unless there's so much mass that it's going to push it all the way down. In that case, you won't have a soft foot. So same way, go around with a feeler gauge. Honestly, the big machines, that's probably the best way to do it, is just go under the corners of the foot with a feeler gauge, checking at least 2 or 3 places around the edge of that foot, and try to get it same way, try to minimize that soft foot. Gabe says, we currently have a fixture laser dials kit. What's the best way to combat angular soft foot? Honestly, the same way we mentioned earlier. I can tell you that sometimes if I've got a really oddball alignment with an odd soft foot, what I'll actually do is sketch out the 4 feet, and I'll take measurements in different places and I'll write those down. What that allows you to do is kind of get a profile of what that angular soft foot is. Some people don't like it, but occasionally you're going to have to cut a step shim, or use one of the plastic shims that are meant to take up angular soft foot. I've even seen people actually machine them, surface grind them with that angle on a sign bar so they can get it to fill that gap exactly. But again, I don't have a problem personally with having to cut a step shim or a partial shim to fill in that gap. The good thing with a partial shim is this: even though you have a taper, you have 1 shim here, 2 here. If the bolt's here, once you make contact on each side of that foot, you're not going to get much compression after that. That's a great question. Do you have any recommendation? Let's see, Victor says, do you have any additional recommendation for hot soft foot measurements? Not any different than the cold ones, quite honestly. A couple things to be aware of when you're doing hot alignment work, beyond the safety items and things like that, because you're in a hot process. Remember that that machine grows in all 3 directions as it heats up. It's going to get bigger vertically, horizontally, and axially. So it could change those values some. But for the most part, unless you're getting some kind of a metallurgical change, you're not going to get an angled soft foot hot and not one when it's cold. At least not a very substantial one, I don't think. These are great questions. Appreciate you sending them in. Jim says, we have lots of small horsepower pumps that sit on skids. It seems like we can never get rid of soft foot. Is there some trick to make this easier? Jim, I'm sorry, but there's not a trick to make it easier. Really not anything different than what we've discussed. A couple things I will give you just as advice. When you're doing these little small skid frame pump and motors, it's a lot of sheet metal. The motor's sheet metal, the riser's sheet metal, the base plate sheet metal, everything's really flimsy and bends easily. When you're attacking soft foot and trying to minimize it, just remember, take careful measurements, and especially when you're tightening the bolts down in the motor, normally we teach making 3 passes in a controlled crisscross pattern like a head gasket or a pipe flange. On these little sheet metal machines, you may have to do a half a dozen or more iterations of tightening, just a little tighter each time until you get it tightened down completely. It looks like we got one from Tyler. Tyler says, we check our motors for soft foot, but we don't check our pumps. Should we? That's an excellent question, and I'll be honest with you, I would. It really doesn't take long to check for a soft foot with a pump or a gearbox or the driven component. It won't affect your alignment so much because you're not loosening or tightening that stationary machine. But to be honest, if you have soft foot in a motor or in a pump, you can tend to get some binding internally, misalign the bearings in the pump. You may have the impeller may actually drag when you tighten it down. Gearboxes especially are susceptible to soft foot problems. And what happens in a gearbox is if the gearbox has a soft foot, you actually, as you tighten, you can pull the gears away from each other, increase your gear tooth clearances. Gearbox gets hotter, makes more noise, and it's damaging to the gears and components. So certainly a good idea to check for that. Ron says, what can you say about special deformable shims for correcting angle foot? I've tried them. They seem to work okay in certain applications. I don't think they'll take up substantial amounts of an angled soft foot, but for the normal soft foot things, they're really not a bad way to go. What I would recommend is do what works best for you. If you want to try some of the special composite plastic type shims, give them a shot and see how they go. You know, I've used them both. I have cut shims purposely to use a stainless step shim. Again, great questions, and the main thing you want is control. Minimize, control your soft foot. Just remember before we finish up here, soft foot really isn't an alignment function. It's an installation quality function, but it has negative effects on your alignment. It's an important part of the alignment process, and it's imperative that you can minimize it or get rid of it. So lastly, if we didn't get to your questions today, certainly we appreciate all that have been sent in. If you didn't hear your name called out, we didn't get to your question, checking your email. We'll do our best to respond to all these as quickly as possible. We hope you'll follow Vibraline on Facebook and Twitter. Subscribe to our Vibraline blog. Go to our website and check it out. You'll find a lot of good information. Lastly, before we go, shameless plug, coming soon, the Alignment Field Guide, which is a collection of stories, tips, and tricks from the Vibraline training team, plus some contributors we have from some of our customers and colleagues. Be looking for this to come out soon. Before I go, I'm Stan Riddle from Vibraline. We appreciate your time for sitting in with us today, and we hope to hear from you soon. Have a great day.